All right, 8.1, which I don't even know if that even matters. That was an old book. But anyway, we're talking about polygons now. So let's talk about a diagonal first. It's a segment that joins two non-consecutive vertices. So what's a vertice? It's these points where you change direction, where you got segments that meet, okay? So as long as they're not right next to each other, that's non-consecutive, you can call those a diagonal. So this and this is a diagonal. This and this are a diagonal. But from here to here would not be a diagonal because they're consecutive. From here to here would be because those are not consecutive. So if it's a diagonal, it can't be right next to the next vertex or vertice. A couple of definitions that we need to know. Concave, you see these words. If any part of a diagonal contains points in the exterior of the polygon. So if any diagonal is outside, so for example, if I drew, let's see if I can find one picture, some of the shapes even. How about this? Now, if you look at this, yeah, I'll stay with that. If you look at this, if I draw the diagonal from here to here, notice how that's outside the figure. That means that this shape is called concave. Convex, no diagonal contains points in the exterior or outside. So this right here would be convex, and this would be concave. So whenever you have those blanks of space, then you can call it concave, and all the diagonals are on the interior, that's convex. And a regular polygon is one that is equiangular. All the angles are exactly the same, and equilateral, all the segments. So that word regular is very important, and I can't draw, but that word regular is very important because it tells you that everything is equal, the sides and the angles. Now this is an important formula or theorem here. The sum of the measures of the interior angles of a convex, it has to be convex, everything's on the inside, n-gon, meaning whatever number of sides you have, you can find by using this formula. N, or the number of sides you have, minus 2 times 180. Also, the sum of the measures of the interior angles of a quadrilateral is 360. So quadrilateral is 4 sides, quad and lateral per side. And again, N is the number of sides. This is very important. So how you find the degree measure of a polygon on the interior angle is by adding all your sides minus 2 times 180. All right, so let's look at this. Here's something that's good to know. You might want to keep in your notes what the names are depending on the number of sides you have. So if I say octagon, you know I mean 8, or nenogon, you know I mean 9, or something like that. And so these names are very important. So these are good references to have in your notes. Now, find the sum of the measures of the convex interior angles of a convex hexagon. Hexagon, 6 sides, and just in case you didn't know that, you can just count 1, 2, 3, 4, 5, 6. So you got 6 sides, and so let's take a look and see if we can figure out